Good afternoon. Myself Dr. P.R. Krishnaveni, Associate Professor of Chemistry, Sasi Institute of Technology and Engineering, Tadapalligooda. Welcome to the lecture on Introduction to Fuels. So, a fuel is defined as a combustible substance containing carbon as the major constituent, which is able to produce large amount of heat that can be used for industrial and domestic purpose. During combustion, carbon, hydrogen, sulfur, phosphorus that are present in the fuel combine with oxygen and release energy. So here combustion we are saying. Here combustion means here exothermal oxidation. Exothermal oxidation of fuel takes place. That is the reason why heat will be released. So, when a fuel undergoes combustion, we will be getting the combustion product. At the same time, heat will be released. If carbon undergoes combustion along with CO2, heat will be released. And hydrogen present in the fuel gets converted to H2O. Sulfur present in the fuel gets converted to oxides of sulfur. Coming to the classification of fuels. So fuels are basically classified as primary fuels and secondary fuels. Primary fuels are also called as natural fuels. Natural fuels means these fuels occur in nature. Secondary fuels are derived fuels. Secondary fuels means these are derived or artificially obtained from primary fuels. So that's why this secondary or derived fuels can also be called as artificial fuels. So again, these natural fuels can be classified as solid natural fuels, liquid natural fuels, gaseous natural fuels. So examples for solid natural fuels we can take as coal, peat, wood, etc. Coming to liquid fuels, we can take the example as mineral oil. Mineral oil means nothing but petroleum. So coming to the gaseous natural fuel. Gaseous natural fuel example is natural gas. Coming to the secondary or derived or artificial fuels. These are also again classified as solid fuels, liquid secondary fuels, gaseous secondary fuels. And examples for secondary solid fuels can be charcoal, coke, etc. And examples for liquid secondary fuels may be petrol, diesel, kerosene, etc. And examples for gaseous Secondary fuels are water gas, producer gas, oil gas, semi-water gas, etc. So these are the various examples of primary fuels and secondary fuels. So here I will show you a few pictures of the solid fuels, liquid fuels and gaseous fuels. So this is the solid fuel, wood, which is a naturally occurring solid fuel, and this is coal, which is a naturally occurring solid fuel. So these are the liquid fuels and these are the gaseous fuels. So here what I said, this is the example for wood and this is for coal, and this is the example of liquid fossil fuel which contains kerosene, and here this one petrol or diesel, depending upon the vehicle. It may be a petrol vehicle or diesel engine vehicle. So coming to the gaseous fuel. So this is the auto which is running with CNG. CNG means compressed natural gas. Compressed natural gas. So this is the cylinder. So these are the some of the examples of solid fuels, liquid fuels and gaseous fuels. Coming to the differences between solid, liquid and gaseous fuels. So coming to the first property, compressibility. Solid fuels cannot be easily compressed. Almost we can say not easily possible. Here liquids can be compressed more than solids and gases can be compressed more. So that's why compressibility will be high for gaseous fuels. And density will be high for solid. Why? Density means in general what's the formula will be saying? Mass by volume. So in general mass will be more for solids. Liquid fuels will have low density when compared to solids, and gaseous fuels will have very low density. Coming to the energy, solid fuel particles have least energy. Liquid fuel particles have high energy than solids, and gaseous fuels will have high energy. Coming to the property fluidity. Fluidity means nothing but we can say free movement. Free movement, or we can say free to flow. Free to flow or free movement. Solid fuels will not show this fluidity. Liquid fuels will show, and free movement will be more in gaseous fuels. So that's why they will show maximum fluidity. Coming to the number of surfaces. Solid fuels may have any number of surfaces. Liquid fuels will have only one surface, and and gaseous fuels will have no surface. Coming to the packing of particles. Solid fuels are closely packed. That means the particles in the solid fuels are closely packed. And the particles in liquid fuels are loosely packed. And the particles in gaseous fuels have large vacant space between them. Coming to the rigidity. Rigidity will be very high for solid fuels, low for liquid fuels, and for gaseous fuels they won't show rigidity. So that's why they are not rigid. Coming to the shape. Solid fuels will have definite shape. Liquid fuels will acquire the shape of the container in which they are taking. And gaseous fuels will also acquire the shape of the container. Coming to the last property, volume. Solid fuels will have definite volume. Liquid fuels will also have definite volume. But gaseous fuels will not have definite volume. So these are the some of the properties of solid, liquid and gaseous fuels. Coming to the advantages of fossil fuels. First advantage is easier to store and transport. Solid fuels can be transported easily. So here fossil fuels we are saying. Fossil fuels means these are nothing but naturally occurring fuels. Fossil fuels means naturally occurring fuels. Here the word fossil fuel indicates carbon rich fuels. Carbon rich fuels. So here what are the examples we can say for fossil fuels? Coal, petroleum and natural gas. So these fossil fuels can be transported easily and typically they are transported through underground pipelines, or through or with tankers. Next advantage, cheap. These fossil fuels are being used from centuries. As they are being used from centuries, we have great and well developed infrastructure. Well developed infrastructure to store these fossil fuels. That means they can be used effectively and available at low cost. At low cost means when compared to the renewable sources. So these fossil fuels are more reliable than renewable energy. Why means the major disadvantage with renewable energy sources is difficulty in storage. Why means this renewable energy sources mainly depends on environmental conditions. Mainly depend on environmental conditions. Why means when wind blows or when sun shines. When wind blows, wind turbines will work effectively. When sun shines, then solar panels, they will work effectively. But when the temperature conditions are not appropriate, in such case the wind turbines or solar panels, they can use only half of their maximum capacity. So that's why renewable energy sources working depends on environmental conditions. But coming to fossil fuels, the energy produced from fossil fuels will not depend on environment. It is purely under our control. So that's why fossil fuels are more reliable than renewable energy. Next, disadvantages of fossil fuels. Not renewable energy sources. As fossil fuels are non-renewable energy sources, on using more, these fuels will run off. As a result, these fuels will not be available for our future generations. Why means fossil fuels are formed as deposits in the underground, and if these deposits are used, then for regeneration they will take several thousands of years. So that's why we have to reduce the usage of these non-renewable energy sources. That means fossil fuels. Next disadvantage is fossil fuels will pollute the environment, especially coal. Coal is the fossil fuel which is responsible for environmental pollution. Why means the combustion matter or the combustion products, they will lead to global warming. But in these fossil fuels, natural gas can be called as environmental friendly fuel. Why means because of its cleanliness. So natural gas is environmental friendly one. But majorly coal will pollute the environment. Next, in case of irreversible use, these fossil fuels may be dangerous. For example, if we take natural gas, natural gas is a combustible one. That means it contains mainly combustible material which may explode. Not only natural gas, even oil Oil is also not preferred to use. Why means in 2010 in 2010 deep oil drilling rig, which is usually called as deep oil origin, or we can call it as deep water origin. So this has exploded because of the explosion of this one. It has led to the pollution of the marine water. So in the history, more amount of oil spilling in marine water has happened because of this explosion. Coming to the characteristics of a good fuel. First characteristic is high calorific value. Calorific value means it is the amount of heat released due to the combustion of a fuel. So if a molecule is having high calorific value means more heat will be released. That's why a good fuel should have high calorific value. Second characteristic is moderate ignition temperature. Ignition temperature means it is the lowest temperature at which fuel is preheated and catch fire. So this catching fire process called as what? Ignition. If suppose a fuel is having low ignition temperature, that means it will be preheated at low temperature and it will be ignited at low temperature. Because of this, it leads to explosion. Not only explosion, it is difficult to store and transport. Such fuels are difficult to store and transport. If suppose the fuel is having high ignition temperature, then for igniting we have to heat more. We have to heat more. That's why a good fuel should have moderate ignition temperature. Next, third characteristic is ash content. A good fuel should have low ash content. Why means if coal with high ash content is used in furnace, then ash produced in furnace it will melt. Why means due to the high temperatures prevailing in the furnace. So that's why it will melt at high temperature and it will form clinkers. Clinkers are bad conductors of electricity. Instead of, they are bad conductors of heat. That's why a good lubricant, a good fuel should have low ash content. Next, third characteristic is moisture content. In general, presence of moisture in fuel, it will reduce heating value of fuel. That's why a fuel should have low moisture content. At the same time, some moisture, some amount of, or we can say small amount of moisture, small amount of moisture is desirable. Why means, if small amount of moisture is present, it will prevent clinker formation. Next, moderate velocity combustion. A good fuel should have moderate velocity of combustion. Why means, if the velocity of combustion is low, then the heat liberated will again reverted back. That means, in short, what we can say, heat liberated will be low. If the velocity of combustion is high, then the combustion process will be uncontrollable. That's why a good fuel should have moderate velocity of combustion. Low non-combustible matter. Combustible matter means, after the formation of the combustion products, ash or clinkers will be remained. These are called as non-combustible matter. If high amount of this non-combustible matter is present, then additional amount must be spent for the disposal of this ash or clinkers. Not only for disposal or for storing. Next one is combustion nature. A fuel to undergo combustion means, first of all, it should have combustion nature. Next one is cheap. A good fuel should be available at low cost, easy to handle and transport. Next characteristic is environmental friendly. Environmental friendly means combustion products formed should not be harmful. So these are the some of the important characteristics of good fuel. Thank you.